Hello guys, welcome to my YouTube channel. So today we are going to discuss one of the most important types of fatty acid oxidation, which is beta oxidation of saturated fatty acids, right? Now the question arises, where does it occurs? Where does this oxidation takes place? So it takes place within the mitochondrial matrix. Okay, so it takes place within the mitochondrial matrix. Now this is very important as there are many competitive exams which ask you the site of beta oxidation. So then you have to write the mitochondrial matrix. Okay, now there are four basic steps in beta oxidation. Four important steps. Let us begin each step one by one. Okay, the first step is called as the alpha beta dehydrogenation of acyl CoA molecule. So suppose we take one fatty acyl CoA molecule. So we are writing here as RCH2, CH2, CH2, C double bond O S CoA. Okay. This is the fatty acyl CoA molecule that I have written. Here we will take a C16 fatty acid, that is a 16 carbon long fatty acid molecule, which is called as the palmitoyl CoA. Okay, so this is called as the palmitoyl CoA because palmitic acid has 16 carbon chain. So here what I have done is I have shown only the 4 carbons. Okay, so only I have shown the 4 carbons, and the rest 12 carbons I am not writing because that is a lengthy chain. Instead, all the 12 carbons I am denoting them as R by a common like alphabet R. Okay, because it is not necessary to write rest of the chain. Only I need these 4 carbon atoms. Okay, so basically keep in mind that although this represents a 16 carbon fatty acyl CoA molecule, I am writing only the 4, rest 12 I am not writing. So what does the name of this first step such as alpha beta dehydrogenation, that means some dehydrogenation or oxidation will happen. So from the general organic chemistry you will know that this is the functional group. Okay, so acyl CoA molecule is your functional group, and the carbon carrying the functional group will be your alpha carbon, and the carbon next to it will be your beta carbon, right? So this is the basic step that you should know. Another thing is that keep in mind this position. Okay, the C double bond O molecule attached to the alpha carbon. Why I am asking you to keep in mind this position, that I will explain at the end of this video because it carries a significance. So now let us begin. So alpha beta dehydrogenation means the hydrogen will get lost from the alpha and beta carbon. So this molecule can be rewritten as, so I have rewritten this molecule. So because it is dehydrogenation, so what will happen, this is your alpha carbon, this is your beta carbon. From these carbons, the hydrogen, each will lose one hydrogen, so this will go out as one hydrogen molecule, and instead what will happen, you will get, what will you get, you will get an alkene formed here. Okay, here double bond formed here. So if we write it as, so the product we will write, but first let us write the name of the enzyme. So this is catalyzed by enzyme called as acyl CoA dehydrogenase, and because this is getting oxidized, so something has to get reduced. So here FAD will get reduced to FADH2, right? So FAD will get reduced to FADH2. So this is the first step of fatty acid, beta oxidation of fatty acid, right? So now we are done. Let's see what will be the products. As I told you, hydrogen will be leave, and so alkene will be formed. So let us write the structure. So this compound that you get here is called as the trans delta square enoyl CoA. Okay. So why trans? Because these two hydrogens, this hydrogen and this hydrogen, are present trans or opposite to each other. So if one is present like this, okay, and another one is present like this, like, okay. So these two hydrogens are present in trans positions, and in because there is a double bond, and oil CoA because it is a S CoA molecule, C double bond to S CoA molecule is attached. Okay. So now this is your first step. So now come to the second step, which is hydration of alpha beta unsaturated acyl CoA. So as you go by the name, it will be hydration or addition of a molecule of water. Okay. So now let us write this structure again. You will add a molecule of water to this molecule. Okay, so this trans delta square enoyl CoA, you will add a molecule of water, and this step is catalyzed by enzyme called as enoyl CoA hydratase. Okay, enoyl CoA hydratase. So here what will happen from basic organic chemistry? This bond will go here, right? So there is formation of partial negative charge, there is formation of partial positive charge on this carbon, and water will dissociate into H plus and OH minus, right? So what will happen? This OH minus will perform nucleophilic attack on this carbon, okay, and OH group will be added to that, and hydrogen group, hydrogen H plus ion, will perform nucleophilic attack on this carbon. Okay, so let us write the structure. What will be the product? The product will be somewhat like this. So I have told you previously to keep this position in mind. The reason I will tell you at the end of the lecture. Alright, so this position, the alpha carbon along with the C double bond O group attached to it. Now this compound that we are getting here, this is called as the L beta hydroxy acyl CoA. Why L? Because it is a L isomer, and beta hydroxy because the hydroxyl group is attached to the beta carbon, and it is a fatty acyl CoA molecule. So this was your second step. So third step is the oxidation to beta ketoacyl CoA. So if you remember from general organic chemistry, if you have a 2-degree alcohol, okay, so if you have 2-degree alcohol, so it will get oxidized to a ketone, right? So here also we have this alcohol that we are getting is a 2-degree alcohol, so we will get a ketone here. So I am writing this structure again here, L beta hydroxyacyl CoA. So now the oxidation will happen. So this is catalyzed by enzyme called as a beta hydroxy acyl CoA dehydrogenase. And here, because something is getting oxidized, okay, so something should get reduced. So here NAD plus gets reduced to NADH plus H plus. Alright, so this is done. So what will happen? We will get a ketone. I am writing the structure of the ketone here. So this compound that you get here is called as the beta ketoacyl CoA. So the final step is the thiolysis reaction. Okay, thiolysis reaction with with an thiol group or SH group. Okay, so what will you do in this step? So you have this molecule. I'm writing it again. So here you will add one CoA-SH molecule. One CoA-SH molecule will get added. Okay, and this is catalyzed by enzyme called as acyl CoA acetyl transferase. So what will happen? This acyl CoA molecule, the beta keto acyl CoA molecule that you have till now. Okay, so this molecule will break. Okay, so you are doing thiolysis, you are breaking this molecule. This CoA-S, okay, this CoA-S group will get added to this carbon, and this hydrogen will get added to this carbon. All right, so what will you have as your result? You will have, so you will have reduced acyl CoA. Okay, reduced acyl CoA, and one molecule of acetyl CoA will be reduced. Understood? So now if you remember, okay, now let's come back to where we started. We started with originally 16 carbon long fatty acid molecule, fatty acyl CoA molecule. And at the end, what are we seeing? We are seeing that one molecule of acetyl CoA is getting released. So one molecule of acetyl CoA has two carbon atoms, right? So in the reduced acyl CoA molecule that you get, this will have 14 carbon atoms. So a C16 fatty acyl CoA molecule gets reduced to a C14 fatty acyl CoA molecule along with the release of one molecule of acetyl CoA containing two carbon atoms. So this is the first cycle. So this what I have shown till now. This is the first cycle, or this is one cycle. So one cycle starting with C16, it reduces to C14. Okay, C14 plus one acetyl CoA molecule. Okay, acetyl CoA molecule, which has obviously two carbon atoms, right? So this is the first cycle. So if you go to the second cycle, what will happen? You will get C12. So again two carbon atom reduction plus one molecule of same acetyl CoA. If you go to third, again one carbon atom reduction, so okay, C10 plus again another molecule of acetyl CoA, right? So in this way, if you go till the end, what will happen? So at the end, the last two carbon atoms which will be left will be released as acetyl CoA. So here you will, so in this way, if you go at some point, you will get the sixth step. You will get C14 plus one molecule of acetyl CoA. Again, you will go, if you go through the seventh cycle, if you go through the seventh cycle, so you will get one molecule of acetyl CoA, okay, and the two carbon atoms which will be left, they will give you another molecule of acetyl. Okay, so altogether in the last step you will get two acetyl CoA molecules. So this is very important. So if you are starting with a C16 fatty acid, if you are starting with a C16 fatty acid, you are getting 8 acetyl CoA molecules through 7 passes or 7 cycles, right? So questions ask that if you have a 20 carbon long fatty acid molecule, how many acetyl CoA molecules will be there through beta oxidation? or how many cycles. Okay, so C20 means 20 by 2, so you will have 10 acetyl CoA molecules and 10 minus 1, 9 cycles. Okay, so in general, you have, if your carbon chain is of 2n, fatty acid carbon chain you have 2n, you have n number of acetyl CoA molecules and n minus 1 number of cycles. Okay, n minus 1 number of cycles. This is very important. Questions are asked. They can give you any random even chain saturated fatty acid molecule and ask how many acetyl CoA molecules will you get, or how many passes will give you this many number of acetyl CoA molecules. Right? This is one. Second thing is why I made you highlight this portion. That is the alpha carbon along with the C double bond O group. So if you sometimes they will say, so if you like radio level this alpha carbon, okay, radio level this or tag this alpha carbon. So if you go through the all the steps, go from step 1 to step 2, step 2 to step 4, okay, sorry, step 2 to step 3, step 3 to step 4, what will you see? So this alpha carbon, if you radio level list, this alpha carbon will finally be in the leaving acetyl CoA molecule. Okay, so similarly, if you radio level the beta carbon, okay, where will it be? It will be in the remaining acetyl CoA molecule. Okay, it will be in the remaining acetyl CoA molecule. So people sometimes in questions they ask that if you radio label this carbon, where will you find in the product? So it will be in the acetyl CoA molecule, leaving acetyl CoA molecule. Whereas if they ask that if you label this carbon atom, where will it be in the reduced acetyl CoA molecule? So that's it for today's lesson. So here comes the end of beta oxidation. We will discuss two more oxidations in this lecture series, which is alpha and omega oxidation.